Okay, guys, so let's talk about net ionic equations. When we're looking at a reaction, there's certain things that take place, certain changes that happen, but then there's some things that are the same on both sides, and we really are not interested in those. We have to have both a positive and a negative ion in a substance, but it doesn't necessarily change from the reactants to the products. In this case, what you're seeing is two colorless clear liquids are being mixed together, and all of a sudden this white substance appears. Well, that white substance is the silver chloride. How do I know that? Well, I look at those subscripts. If it's aqueous, it means it's dissolved in water. If it's a solid, it means now it's a solid, and that's what that cloudy stuff is very finely divided solid that's kind of dispersed throughout the medium. If I give it a little while, it'll eventually settle to the bottom, and I'd still have a colorless solution. So sometimes we're interested in just what's changing from the reactants to the products. So when sodium chloride dissolves in water, it will separate into sodium ions and chloride ions, and those are already there. Then when I add the silver nitrate, silver is dissolved and nitrate is dissolved, and they are separate ions surrounded by water molecules. But when those silver ions come in contact with chloride ions, they are not very soluble. In fact, they're very strongly attached to each other, and so they form that solid. The first word that you need to know is complete ionic equation. And that means that you show everything that's AQ as individual ions. And so in this case, everything's 1-to-1. So I get one silver ion, one chloride ion, one sodium ion, and one nitrate ion. If it is solid, liquid, or gas, it stays together in a complete ionic equation, and that's why AgCl is still put together. Now we can start to cancel out things that appear on both sides. So if something is both on the right-hand side and the left-hand side, or reactants and products, identical in number and charge, we can cancel them out. They're what we call spectator ions. They didn't do anything, and they're just hanging out because they're there to begin with. And so we could cancel out those 4 ions, 2 on each side. So those are our spectator ions. And to do a net ionic equation, you need to first do the complete ionic equation, and then you can do the net ionic equation where you would rewrite it without those ions, those spectator ions. And so the net ionic equation is just the things that are changing, so we can focus on those and not see things that are just hanging out. So when we write a balanced net ionic equation, we do have to make sure that the charges are balanced. In this case, there's 0 on both sides. Sometimes they will not be 0 on both sides, and that is possible, and that is fine. It just means that both mass atoms have to balance and charges have to balance. So let's look at this one. What things am I going to break apart? I'm going to leave lead by itself. I'm going to take AgNO3 and I'm going to break that apart into ions. And then I'm going to leave on the product side silver, and then I'm going to break apart the lead to nitrate. And so nitrate will be a spectator ion. And when I eliminate the nitrate, I get that, and we balance it, then we get that 1 lead plus 2 silver ions is going to give us 2 silver solid atoms and 1 lead 2 ion. So a net ionic equation shows only those particles involved in the reaction and is balanced with respect to both mass and charge. I'm going to stop here, guys, and I hope you have a great Easter break.